Procedure's the same for both instruments, base, column. Unscrew the screw from the column, because it will be delivered. If it's delivered via FedEx, it will be delivered in a big box with polystyrene packing, or everything separate. You have to unwrap everything, which will be covered in bubble wrap. Align the holes. Use your key, this key. Say if it's screw won't go in it first, just jiggle it till you get the hole fully aligned, and then lock it. Never over tighten, there's no need, just enough to lock it. Column down. Instrument again, unlock here. Place over the top, and then the same thing, should have the friction to go up and down, but not too much, not too little, so if you let go it shouldn't fall, but you can just slide it. So, and this will wear in with time a little bit, so we need it to be a good friction control. The same things is here, we need to unlock. I will have locked this, wound it up so this can go up and down. There's no measurement for this, this is just for working. This is just a fine height adjustment, but it doesn't measure anything like the other instrument. This is just facilitates our working procedure. But I will have locked this. This is the angulation locking screw, friction screw. So turn it half a turn, and now I can turn this. If I turn it too much, it falls towards the sensor. So I need to get a little bit of tension on there so it doesn't fall anymore. I can still turn it with my hand, but it doesn't fall. And that is just a simple adjustment here, according to how much tight you want it. Some people like it tight when they're making measurements, so it's harder to move, but easier to control the amount we move. Friction control. Same underneath for the torque. Underneath here, we have to loosen, that's locked. We loosen that. Half a turn, and now we can turn this up and down. That's the torque knob. And that's the torque blade. Angulation knob. Changes the angulation of the blade. Gross height adjustment, fine height adjustment. These are the sensors. You don't need to worry about them. So, the same thing, we plug in, same way. Just one way that this will go, like a printer plug. And then the instrument comes on. 0 and 0. Angulation measures 0.5. It actually measures 0.1 on the sensor, but we regulated it to be 0.5 because 0.1 movement by hand is just too difficult. And we don't need it for orthodontics. 0.5, 0.5, 0.5, 0.5. So coming back, that says plus, because that would be as if we're measuring the left side of an upper arch. This is the base. Base is very easy to use, just like any surveyor base. You just unscrew here to remove your model. Place the model, tighten it, lock it. This allows us to move the base and then locks the base. And just like any surveyor base, just easy to use. So, angulation will change from the left side of the arch to the right, but torque never changes. I'll just show you how to use it. we get the model, we've got the base, we can move it. You can move it to whatever plane you want. If you want to survey from a particular plane, you set that plane by reference points. With a dental surveyor or with the edge of this, you can align 3 points, 4 points, whatever. But the function of the instrument, that's what I'm showing you here, not how to do your orthodontics. Function of the instrument is, this is up and down with a linear slide. So you want this in the mid-range before you start measuring a model. Mid-range. And then bring the gross height adjustment down to approximately the middle of a tooth. There's a mark in the middle of the blade, and you want to align that with the FA point, the middle of the clinical crown on the long axis. So, for instance, if I'm measuring the left side of the upper arch from 21 to 27, first I have to make sure that I'm measuring correctly, positive or negative. If the blade is leaning towards this midline at the top, it's positive. If it's leaning away, it's negative. Tip. Angulation. But when I come to the other side of the arch, now it's wrong. It's leaning away, it's positive. Leaning in towards the midline, it's negative. So we just press this button and it changes it. Just one press, not hold it, just press. The other button is not any function, don't need to use it. The other button is for later modification to the electronics if we need to, like a download or Bluetooth or something. So if I'm now measuring the 11, I would just bring up the height with the fine height adjustment until the middle of the blade is corresponding with the FA point. I look down the blade and make sure that my tip of the blade, the angulation of the blade, is parallel with the long axis of the clinical crown. That gives us our tip. And then this adjustment here gives us our torque. As I change the blade, my corresponding middle of the blade with the FA point has changed, so I just adjust the height a little bit. And torque. The trick is also not just to fit the blade to the tooth. Here, it's a measuring torque. We see that tooth retrocline, so we have a torque of 4.3, minus 4.3. The trick is also to look at the space between the blade, zoom in on the space here, between the blade and the tooth. Because if we fit the blade to the tooth, then maybe the morphology of the tooth will trick us. So we want the general inclination of the tooth. And that measures the torque. Inclination. Simple as that. The tooth can be surveyed in 30 seconds. Once we've set the plane, you can measure a tooth, you can move to the next tooth on that side of the arch, set your tip, set your height, set your torque. And then you get an idea of what that tooth is in real values for tip and torque. Torque 1.5, tip is +6. Same, we move round. Very quick, very easy to use. That's it. We have another measurement, minus 2.1 for the canine, torque and tip of +2.5. That's quite upright. So you can use these values in your planning, your treatment planning, so that you can make personalised treatment plan for the patient, not just stick to a standard chart. You can measure the teeth and then decide roughly how much you want to move them. So you have an idea before you start what we started with, what's my goal. So if we come back to this side of the arch, it's wrong now because the tip is wrong, so I just press it again, and now I can measure 21. You see now why I use a stand, so I'm looking. I'm not, if I was on the bench I'd be doing this. I get a very stiff neck after half an hour. So best to use this on an elevated stand. I made this turntable myself. You can make a turntable, you can buy a Chinese dining table, you can put it on a box, whatever. This is a turntable from an index Chinese dining table that I removed, and then I use it for shows. I don't want to transport this, and also for bonding in the lab, so I can just turn this, because this you want to be above it, you don't want to be down it, you want to be above it, to look when you're placing your brackets. This one, you want to look at it high level. That's measuring. If I want to set this tooth to a predetermined torque, let's say I want to set it to 10 degrees of torque, I want to increase that retroclination and change it to a positive torque, then I set, this is, let's say 0, I want 0 tip, 10 degrees of torque, I can do that. We just set the instrument and then change the tooth to fit the instrument. So now we use the survey base to fit the tooth to the instrument. The same way as we did using the old Torque instrument from Monco, which had separate blades for each tooth. Now I fit that tooth to the instrument, lock it, and that one tooth, the 21, has been programmed in time, in space, to tip and torque, individualized.